Welcome grade 11s, and in this pre-video we'll go into a whole lot more details and the examples coming up. Just want to look at these ways to prove that a quadrilateral is cyclic. And the way to do it is to use one of the theorems we've already seen, but kind of in reverse. So we're going to use this keyword converse as our reason in each case. So let's look through the three, and then our examples will show how this works. So if we are given a quadrilateral, so here's a quadrilateral, I just want to highlight it here. There, this will get us there. Okay, so we got quadrilateral A, B, C, D. And we need to prove that it's a cyclic quadrilateral. In other words, we can draw a circle through all 4 points. So that's not always going to be true, but we need to prove that this is true given a particular quadrilateral. Well, one way to do it would be to show that the opposite angles add up to 180. In other words, it's almost like opposite angles of cyclic quad is true, therefore cyclic quad. If you were given this scenario here as a circle, you would immediately say A plus C equals 180 because cyclic quad. So we're just doing that kind of in reverse and going, well, if we could show that, so let's say that we're told that this was 80 and this was 100, then we go, yes, definitely cyclic quad because 100 plus 80 equals 180. Now, you only have to do it for one pair and think through why you don't have to show it again for the other pair. Okay, so only one pair you need to show. It could have been A and C, or it could have been B and D. So if you can show that, then great stuff, cyclic quad. Okay, second way we might do it, and that is to show that the exterior angle equals the opposite interior angle. So again, it's kind of one of those ones, we know that it's true if we've got a cyclic quadrilateral that goes here, there, or if we've got a quadrilateral and we can show that that angle on the exterior is equal to this angle. So for example, if we told this is 100 and that's 100, then it means that A, B, C, D is a cyclic quad. In other words, you can draw a circle through those 4 points. Okay, so our reason, converse, exterior angle of cyclic quad. So it's the same reason you remembered, but you must use this keyword converse in front of it. In other words, or the way I think about it, it's almost like you're using the reason in reverse. Okay, so the last way you could do this is, let's say we're given 4 points, and this is our last picture at the bottom here, and these points, here they are. Let's say that that was like A, B, C, D. If we could show that angles in same seg was true, in other words, that the angles in the same segment were equal. So if we started from, say, that point, let me get this shape is what I want to use for my thinking, and we subtended or created that angle there, and we started from the same 2 points and created or subtended that angle, if they're equal, then must be cyclic quad because it's like we've created an angles in same seg situation. So where this angle equals this angle equals this angle. Okay, you're going to see an example. The very next example in the next video will use this very theorem here. So you're going to see it in action. I'll see you in the next video.